Question 18. A student investigates the link between the volume and pressure of a gas. The student uses a fixed mass of gas in a closed container. So something like this. Lovely. Let's pretend it's ideal as well. The student plots the graph of the results. Pretty scary looking. Ah well, let's see what we've got to do with it. The student thinks that pressure multiplied by volume is always equal to the same number. So P times V equals some kind of constants. Hopefully that's ringing some bells. Explain why the student's correct. Use data from the graph to support your answer. At GCSE, we don't really go into many details of how an ideal gas behaves like this. It's just something we have to know. So what we need to do is focus on this part of the question, which asks us to pluck some data from the graph. So let's pluck some data from the graph. There we go. That point there. So volume equals 25 centimeter cubed, and pressure at that point is 100 Pascal. So 25 multiplied by 100 is equal to 2500. We'll leave that without units for the time being because we don't really need to know that. It's just a constant. It relates to energy if you're interested. Let's pick something else. Let's pick this part. Why not? Volume equals 5 centimeter cubed. Pressure equals 500 Pascal. So 5 times 500. Let's give the calculator another whirl. What a surprise. 2500. So we've shown that the student is correct. I've had a quick look at the mark scheme for this, and there doesn't seem to be anything about using a prose explanation as to why the student is correct. The mark scheme is all about using this data to prove a point. So there we are. Question 18b. Complete the sentences to explain how volume and pressure are related. Use words from our list. We can use them as many times as we want or never at all. So we've got a gas in our container. Let's make it a really easy one with two particles bouncing around, minding their own business. If the volume of the gas is halved, the number of collisions per second between the gas particles and the container is doubled, halved, or the same. Now, what we're doing here is reducing the space that our gas is in. So our two particles in our little model here are occupying a smaller space. So when they bounce around, they'll end up hitting the walls of the container more often or more frequently. It doesn't take them as long to get to either wall. In this case, our choice is to use doubled. Okay, and therefore the pressure is doubled, halved, or the same. Well, what we've got here is our particles bashing on the walls more frequently. So therefore there's a greater force because we've got those impacts happening more regularly, so that's also doubled. Question 18c. The student then investigates how temperature and pressure of a gas are linked. The student measures the pressure of a gas as its temperature increases. The results are plotted on a graph. Here we go. Explain how temperature and pressure are linked. Use a graph to support your answer. Now, to explain this graph, we first have to describe it, because once we've described what the graph's telling us, we can then explain what's going on. So first things first, we can see that as the temperature increases, our pressure also increases. So as temp increases, pressure increases. You can also say as the temperature decreases, the pressure decreases. It means the same kind of thing. Notice how the graph is a straight line too. I mean, what we've just written could also apply to a graph in this shape. So let's mention that too. So the two variables, the pressure and the temperature, have a straight line relationship. I try to avoid saying just linear because, well, technically speaking, this curve here is linear because it's a line, which just happens to be a curve. So it's a straight line relationship. Avoid saying proportional because for a graph to be proportional, it has to go through zero. Otherwise, you don't get that doubling of one variable doubling the other. So we can't say it's proportional. It is a straight line relationship though, so we'll say that. Now, we've described a fair bit. We haven't explained anything yet. So let's talk about some gas physics. So as temp increases, if we consider our particles in our makeshift box before, the way that they're exerting a pressure on the box is moving around and colliding. So as the temperature increases, particles are moving faster. And we can say two things here. We can say they collide more frequently with the container, and they also collide with a greater force because they're moving faster. They're hitting the container much harder. And both of these things increase pressure.